a concern and an interest in that area, in science, and what the Bible says of it, and how we are to defend Scripture in that sphere. And so Spike's videos were an invaluable resource for our church. And I had the privilege of finally meeting him and getting to know him, and now he's going to speak. So please welcome Spike Psarris.
Good morning, everyone. It's my privilege to be here with you this morning. If you can get the lights, please. I have some slides that are a little bit darker than perhaps typical. First of all, I'd like to spend a moment explaining why I'm here. I was an atheist until well into my adult years. My educational background is engineering and physics, and I was an atheist because of that education. I had been taught science disproves the Bible, disproves the Creator. We knew how everything got here without one, so the Creator was neither desirable nor necessary, according to my worldview. And I was working as an engineer in the military space program when I was confronted with evidence against my atheism and my evolutionism. And let me emphasize that point. I was an atheist because I was an evolutionist. I had been persuaded by science education that evolution was true, the millions of years, the natural processes, and all the rest of it. And so that, in my mind, disproved the Bible as a credible source of history. And it wasn't until being confronted with evidence against those beliefs that I eventually became a creationist and then a Christian. That process did not happen overnight. I spent a long time trying to disprove the creation viewpoints of the Christian coworker who started to discuss all this stuff with me. And the process happened in that order. I became convinced of creation first before becoming a follower of the Lord after that. And I like to mention that when I speak for a couple of reasons. Number one, our culture tells us that Christians are creationists only because we have to be, because the Bible says creation is true, and that we're blinded by our faith, our pre-commitment to the Bible as true. And if we could take these blinders off, if we could see science objectively, then surely we would perceive all the evidence for the millions of years and the neo-Darwinian processes and all of that. I'm one of many, though, for whom the opposite is true. I became convinced by the evidence first of creation. That then opened the door to me becoming a Christian. And I also like to mention creation is not sufficient to make one a Christian, because that's the work of the Holy Spirit. I mean, there are Muslims who believe in creation, right? But our culture has really, the evil one has really used science as an effective weapon, or I should say distortions of science, in an effort to discredit God's Word. And so I think this is a topic worthy of our time. There are many in our society who are like me, who disbelieve in the Bible and are denying their Creator because of what they think science has to say. Well, as we will catch a little bit of here this morning, science actually is on our side, not on the other side. So when Jebby asked me to speak, I said, well, astronomy is such a big topic, we could spend days in all the ways that the heavens proclaim the glory of the Lord. But since the coming solar eclipse next week is going to be in the news a lot, I thought this would be a good theme for our subject here this morning. I'll mention first of all, if any of you are planning to go to see the eclipse, safety warning, make sure you're wearing your eclipse glasses. And I was going to wear these during my talk this morning, but then I couldn't see anybody, so that's not going to work. Here in Washington, we will not be in the path of totality. We'll see a partial eclipse, not a full one. But I know several of us at least are going down to Oregon to see totality. So what is an eclipse anyway, and how can we perceive our Creator's glory within it? Well, there are three bodies involved in an eclipse. That, of course, would be the sun, moon, and earth. So when the moon happens to pass in between the sun and the earth, then the moon's shadow here will cause an eclipse. Now this, of course, is not the scale, but you'll see that the moon casts a lighter shadow here and then a total shadow right in the middle. And here's what this looks like from space. This is actually from a Japanese satellite. This is the shadow of the moon on the earth causing the full eclipse. So here in Washington, we'll be in this outer area where it's not full, but there in the middle, if you want to just drive a little bit further south, you'll be able to see for several minutes a total solar eclipse. And if anybody's in doubt, still thinking about whether or not you should make the effort, it's well worth the time. Often these happen like in the middle of the Pacific Ocean or something, and people get on cruises and spend thousands of dollars to go see it. And here we are, we only have to drive a few hours. So anyway, I won't try to market that anymore. But while we're talking about these objects, where do they all come from? Earth, moon, and sun. Okay, they're all involved in this. What is their origin? Well, the Bible tells us that in the beginning, God created the heavens and the earth. And it tells us furthermore that there were several reasons that he did that. He created them for signs and for seasons. He created them to sustain life here on earth as a habitable place for us, and also to declare his glory. Genesis 1 explains that God said, "Let there be lights in the firmament of the heaven to divide the day from the night. Let them be for signs, for seasons, and for days and years." God made two great lights, the greater light to rule the day, and the lesser light to rule the night, and then he made the stars also. And I would hope these are familiar passages to us. Of course, this is not a popular view in our culture today, is it? The resounding view is secular. And the secular view is an effort to deny the glory of the Lord as revealed in the heavens. So we're going to spend some time here this morning talking about the secular view of things and how it doesn't work. Science thoroughly discredits this outlook. Let's start by discussing the earth. Where did the earth come from? Well, ultimately, the earth formed, along with the rest of the universe, as a result of a alleged Big Bang event almost 14 billion years ago. There was this quantum fluctuation of the vacuum. The Big Bang occurred. That made a lot of radiation. The radiation cooled and formed into matter, which formed into gas, which gathered into things around us today. And there's many, many problems with this. I have a whole presentation focusing just on that part of the secular worldview. Our time this morning, though, we're going to focus just on the very end, chronologically, of this idea and talk about the solar system. Now, does the solar system look like it came from this type of process? Well, the secular folks will tell you that they have a model describing how all this happens. It's called the solar nebula model. Now, a nebula is a cloud of gas out in space, like the Orion Nebula that I'm showing you here. And solar, of course, refers to the sun. So the solar nebula model is the idea that our solar system came from a nebula, a cloud of gas out in space. So the story goes something like this. In the beginning, there was gas. About 4.5 billion years ago, a large cloud of gas formed and started to collapse under the force of gravity. From that gas, dust particles condensed, which then began to stuck together to become clumps, which stuck together to become little rocks, which stuck together to become bigger rocks. The bigger rocks stuck together to become what are called planetesimals, which means little planets, basically asteroids. And then those stuck together and gathered together in various ways to form the planets that we see today. Minor problem with this model, I mean, that the textbooks will tell you this is true, this is well-proven science, etc. Minor detail, though, is that this model doesn't actually work. It doesn't actually produce planetesimals. There's problems getting dust from the gas, but we'll grant them that for the moment without going into detail. And once you have dust, particles will stick together, right? Just look into your furniture for proof of that. And maybe the clumps will stick together beyond that. But once you get to particles, chunks of material about this big, the process stops working. Why is that? Well, when you have rocks about this big and you smash them together at a couple thousand miles per hour, does that make bigger rocks? No. It makes rubble, right? Now, here's the problem. When the rocks are about yay big, there's enough mass there to be destructive when they collide, but there's not yet enough mass to have enough gravity to pull the rubble together and make bigger objects. So this planet building process stops right about here, 1 meter in size, give or take. Are secular scientists aware of this? Well, yes, they are. Here's a quote from one of my astrophysics textbooks. Once these planetesimals, these little planets, have been formed, further growth of planets may occur through their gravitational accretion, their gathering together into large bodies, but just how that takes place is not understood. The formation of planetesimals, or these asteroid-like things, the kilometer-sized planetary precursors, is still a puzzling process. How the first stage of this process, primary accretion, works is a fundamental unsolved problem of planetary science. Now, those of you who like science going to museums, watching programs or whatever, who has heard this problem discussed? Is it presented that, well, we can't actually make anything bigger than this in our models? Or is it presented as, oh no, we have this all figured out, this is good proven science? Well, the latter view is what's presented, but the former view is what's actually at work behind the scenes here. So how do secular scientists deal with this? Well, here's the currently favored explanation. See if you think this is a good scientific model. Objects must have grown very rapidly from sub-meter-sized pebbles into 100-kilometer-sized bodies, perhaps or possibly in a single leap. So rocks this big turned into asteroids the size of Rhode Island. Is this a good scientific model? Or is this a hand-waving story? Well, it had to happen somehow because we're here, right? Logical fallacies galore in that statement, of course. So the secular modeler actually has no building blocks, so to speak, to explain how anything in the solar system got there. Beyond that, though, he has additional problems. Each of the objects in our the large objects in our solar system, the planets and so on, poses additional problems for the secular model. And we could spend a whole session just talking about this. We're going to limit our attention here this morning, though, to the Earth, Sun, and Moon. This graphic here is to scale for size, but not for distance. So this is roughly how big everything is compared to each other, if you will. You can see the Sun is much bigger than all the planets, and the Earth, you are here, basically, right on that little dot. The Earth is not all that big, but of course it's the most important object in the solar system, because that's where we are. The secular modeler, though, not only has no building blocks to make the Earth from, there's additional features of the Earth that he cannot explain. For example, the Earth is covered with water. 70% of the surface of our planet has water on it, right? Problem is, though, the secular model says there should be no water here. This model makes very specific predictions about what elements could condense out of that gas cloud at various distances from where the Sun was forming in the middle. Of course, the closer you get to the middle, the hotter it is, right? Well, the Earth is close enough that it would have been hot enough here that water could not have condensed out of the cloud here. Therefore, the secular model says the Earth is bone dry. Is that what we see? Well, no. Now, for a while, the preferred secular explanation of this was that early in the Earth's history, it was bombarded with millions of comets from the outer parts of the solar system. Now, comets are big, dirty snowballs and ice balls out in space. They're made of, to some degree, water, so their explanation was that's where the water came from. Problem is, we have since then been studying the composition of comets, even able to take samples in some cases, which is technologically pretty hard stunt to pull off, but we've been able to do that. Turns out that there's some isotopic differences between comet water and the Earth's ocean water. What that means is the Earth's ocean water could not have come from comets. That left secular modelers back in the same position of having an Earth that's bone dry, which of course is contradicted by the actual evidence. So today the preferred explanation is that instead of comets, the Earth was hit with millions of meteorites early in its history. Rocks from space. How much water do rocks from space contain, though? Do you want to try to account for all the Earth's water? Not merely the oceans, by the way, all the water in the mantle as well. Well, that's not a good explanation, but it's nevertheless the one that's presented and taught as truth because there's no better explanation to offer. In addition to that problem, our magnetosphere, the Earth's magnetic field, poses some challenges to the secular model. The secular model is based on the idea that the Earth is 4.5 billion years old, more or less, a little bit more than that. The problem is our magnetic field says it's not. Our magnetic field is actually has a lot of indicators that it's actually very young. We've been taking good measurements of the field strength since the early 1800s, and since 1829, its total energy has fallen by about 14%. Our magnetic field is decaying in strength. And if you do the math on this, it loses half its energy every 1,400 years or so. That means 1,400 years ago, 600 AD, the field was twice as strong as it is today. 800 BC, it was 4 times as strong. 2 times the twice, right? Every 1,400 years you go back, it's doubled again. Now, I should clarify, I'm not talking about polarity reversals here. I'm talking about the total amount of energy in the field overall. So why is this important? Because The strength of the magnetic field is believed to be the result of currents inside the Earth's molten core. And those are in turn related to the amount of heat being produced in the core. The heat is what's driving this whole process of producing the field, supposedly, according to the secular view. So the stronger the field used to be, the more heat used to be inside the Earth. Is there a limit to how hot the Earth could ever have been? Well, yes, you can calculate how much heat would be necessary to melt the Earth's crust. And since there's no evidence that that has ever happened, we can say that's the maximum amount of heat that could ever have been. We can calculate that maximum amount of heat would be reflected by what strength of magnetic field, and from there you can calculate how old the magnetic field can be. Did everybody just follow that? Okay. Point is, the upshot of all this is the magnetic field in its decaying and what it's telling us about the inside of the Earth can only be thousands of years old, not billions. About 20,000 years ago, this field would have been so intense that the heat inside the Earth would have been so intense that the Earth would actually be molten. It'd be melted. So maximum age for the Earth by this indicator is about 20,000 years, not 4.5 billion years. Now this is also not to say that the Earth is 20,000 years old. That's a maximum age, not a minimum. 6,000 years works just fine. What doesn't work is 4.5 billion. And some secular modelers will even admit to this. As this author said, magnetism is almost as much of a puzzle now as it was when William Gilbert wrote his classic text concerning magnetism, magnetic bodies, and the great magnet Earth in the year 1600. 400 years this has been a head-scratcher for those who wish to deny the Earth's creation. So those who try to deny the Lord's creation don't do very well when looking at the Earth, because, indeed, the Earth declares the Lord's glory instead. The Earth is uniquely designed for us to be here, uniquely designed to sustain life. And even many secular authors have admitted this. Here's two books that were both fairly popular and sold a lot of copies. These are not written from a creation perspective. They accept the billions of years and all the rest of it. And even they admit the Earth looks uniquely designed. For example, I talked about the fact that water can't be here according to that secular model. Well, water, of course, is very necessary for life. In fact, if you look at the studies of people looking at other planets elsewhere, they will often say, oh, we found a new planet around star such and such that's in the habitable zone. The habitable zone is that narrow band of distance, that narrow region within which liquid water is possible. And by the band, I'm talking about distance from the star that the planet is orbiting. If you're too close to the star, then it's too hot and you don't have liquid water, you had steam. If you're too far away, you have frozen water, ice. There's a narrow band of distance from any star, though, where liquid water is possible. That's called the habitable zone. Now, secular scientists like to portray this as if once you're in the habitable zone, you get everything you need for life. Well, that's not true at all. We see this right in our own neighborhood. Are there other objects in our solar system's habitable zone other than the Earth? Yes, like our moon. Is the moon a nice place for life? Well, no. You need a lot of other things other than being in the habitable zone in order to be a nice place for life to be possible. In the Earth's case, we have a very protective magnetosphere. I told you a moment ago that our magnetic field is a good indicator of the Earth's youth. Furthermore, it also is a design feature to protect us from harmful radiation from space. Without our magnetic field, life here would be not like it is today. It would be a very hostile environment here. The Earth's rotation period, almost 24 hours to go around our axis once, right? That's where we get our day from. Now, we take that for granted, right? I mean, how many people woke up this morning thanking the Lord for a nice rotation period for our planet? Well, it turns out there's a wide variety of things that are possible. For example, Jupiter's rotation period is 10 hours. On the other hand, Venus takes 243 Earth days to go around once. Now, it turns out that 24 hours is just right. It's a nice Goldilocks number. If we had a rotation period like Venus, we'd have extreme winds on our planet, very hostile weather, like Jupiter. Conversely, if we had a very slow period like Venus, then any given point on the Earth's surface would either be exposed to the sun for a very long time or cut off from the sun's warmth for a very long time. So you'd either be freezing or roasting. Either way, life here would not be like it is now. Our axial tilt, 23.5 degrees as we go around the sun. Again, we tend to take that for granted. But look elsewhere in the solar system. Mercury basically has no axial tilt. It's almost perfectly perpendicular to the plane of the ecliptic. So Mercury doesn't have any seasons. Mercury has many other problems too for the secular model, but we'll skip that. On the other hand, Uranus is almost perfectly over on its side. So that means one particular pole is going to be pointed at the sun for a good portion of its orbit. So on the one hand, you have no seasons here. On the other hand, you have extreme seasons here. The Earth, however, because we have a moderate tilt, has moderate seasons where various parts of the planet are warmed at different times, and makes this a nice place for us to live. Our orbit is very circular. Again, we take that for granted, don't we? We don't think about that. Well, there's extremes of that elsewhere in the solar system. For example, Mercury has a more eccentric orbit, a more oval-shaped, if you will. And Mercury, at its closest point to the sun, actually receives twice as much solar radiation as it does at the furthest point away. And you can imagine how violent of a swing that would make to your climate change, right? But again, the Earth is just right, nice and circular. Our atmosphere. Now, we don't have a very thick atmosphere, really. Most of it is contained within the first 20 miles above our heads, which isn't much if you think about it. But if you could drive at highway speed, if you could go straight up instead of sideways, you'd be in space in a couple of hours. Space is really close to us, and given such a hostile environment, that's kind of sobering if you think about it. But our atmosphere is thick enough to protect us from harmful radiation from space, along with our magnetic field, as I described earlier. Yet our atmosphere is not very thick. It's about the same thickness relative to Earth as the skin of a peach is to the fruit itself. So that's how thick our atmosphere is. Turns out if our atmosphere were a little bit thicker, you'd have a runaway greenhouse effect, which is what Venus has. On the surface of Venus, now again, Venus is often called Earth's sister planet because it's about the same size in mass and so on. The pressure under Venus's atmosphere is 90 times that of Earth's, and the surface temperature is almost 900 degrees Fahrenheit. That's what happens if you have too thick of an atmosphere, but the Earth's is just right. More we could talk about this subject, but the main question is, does this look like the outcome of random processes after this Big Bang? Or does it look designed for life instead? Now, as Christians, it doesn't surprise us that the earth looks very well designed, because the Bible says it is. Thus saith the Lord that created the heavens. God himself that formed the earth and made it. He established it, created it not in vain. He formed it to be what? Inhabited. I am the Lord, and there is none else. So the Lord made the earth for us to live here, so we shouldn't be surprised that it's very well designed to do that. With all these various features, uniquely designed for life, plenty of water on its surface, as a reflection of Noah's flood, incidentally, even though the secular model says it shouldn't have any at all, and our magnetic field is a good indication of youth. So the Earth is one of those three bodies involved in this upcoming solar eclipse. The one casting the shadow on our surface is, of course, the moon. Now, where did the moon come from? Well, the secular people have been hard at work trying to deny the Lord's glory and trying to come up with an alternate explanation for the moon. And that was actually one of the purposes of the Apollo program. The Apollo astronauts actually brought back several hundred pounds of samples of moon rocks with them. And one of the reasons that was done is because at the time of the Apollo program, there were three competing secular theories about where the moon came from. And I won't bother explaining them because it turns out the samples disproved all three, which was kind of fun. So for a while, secular modelers had no explanation for where the moon came from. Today, though, you'll be told that there's a good explanation. That early in the Earth's history, a Mars-sized object crashed into the Earth, the debris sprayed up into space, and some of it formed into our moon. Now, the museums, the textbooks, the programs, etc. will all tell you this is good science. Well, right out of the gate, it was obvious this wasn't good science because this model is extremely contrived. But beyond that, there's good evidence showing it didn't actually happen anyway. For example, the Apollo astronauts, among other things, brought back soil samples. And in the mid-2000s, these samples were reanalyzed to see if there's anything that the original analysis missed back in the 70s. And it turns out there was some things missed in the samples back then. We now know definitively that some of the volcanic glasses contained in the soil samples contain water. Now, water on the moon's surface has been known for a long time, and that's not a big deal because that could have come from comets or meteorites or whatever. But this whole idea here says where water cannot be is inside the moon, because this violent collision would have vaporized any water that was present. There would be no water in the material that then subsequently formed into the moon. But we now know, again, since the mid-2000s, that there is water in volcanic material. That means there's water inside the moon where the material came from. And that means this thing never happened. Yet you will still be told that this is what happened, that this is where the moon came from. Why is that? Even though there's no evidence showing it didn't happen. Well, that's because there's no other model for them to offer. I don't think that's good science or good education. And I'm going to skip forward a little bit in the interest of time. So there's other problems with the moon from a secular perspective that we could discuss, but here this morning let's talk briefly about the positive evidence for the moon actually being uniquely designed for us. Well, there's actually lots of this. For example, you probably haven't thought of the moon as being important for life on Earth, but it turns out that it is. The tides that the moon raises in the Earth's oceans help keep the ocean cleansed, if you will. The tides create circulation that prevents the ocean water from becoming stagnant. Were the moon not there doing that, there's a high risk of at least portions of the ocean becoming stagnant. Things within it would die, and then that would affect the whole food chain. But the moon is very well designed to prevent that from happening. It's also uniquely positioned. Next week we're going to see a total solar eclipse where the moon just passes right in front of the sun from our perspective and blots out the disk perfectly. Well, the moon is 400 times smaller than the sun is, but it's 400 times closer to Earth than the sun is. So that means its apparent size from our perspective is the same. There are over 163 moons throughout the solar system. Our moon is the only one that has the proper combination of size, distance, and alignment in its orbit to just produce total solar eclipses for observers on their surface. Now that's either an amazing coincidence or it's evidence that indeed these objects were designed to declare the Lord's glory and to provide signs and seasons for us. The moon is also uniquely stabilizing. Studies have shown that without the moon there, the Earth would be at risk of our axial tilt becoming chaotic, and the Earth would actually be doing this in space. But because of our moon, it doesn't do that. From 0 degrees to 85 degrees would be our axial tilt. Imagine how violent the climate would change here if our planet was doing this. But it's not doing that because the Lord put the moon there. Now again, this also presupposes the millions of years, which we would not accept. But it's interesting to me, and a lot of these things, that the Lord has designed things in such a way that even if you do accept the millions of years, you're still up against all this evidence that design is evident. Because indeed, the moon is uniquely designed for us, and also fulfills its purpose very well of being the lesser light to rule the night. And of course, quoting that verse brings to mind the other part of that, which is the greater light to rule the day. So let's talk about the sun for a few moments. Now the sun, this is perhaps more obvious than the moon was, the sun is essential to life on Earth, right? Obviously without the sun here, we would not be in such a warm environment as we are today. The Earth has a little bit of internal heat from radioactive decay, but not much. Life would be impossible here were it not for the warmth of the sun. The sun also produces our food in all of its various forms. Sunlight is, of course, essential for plants to grow, and we eat plants, and then we also eat things that eat plants. Either way, without the sun, the basis of that food chain would collapse. We would have no food for us. You might not have thought about the fact, though, that the sun also is responsible for the oxygen that we breathe, because that's the result of photosynthesis from plants receiving sunlight, right? So the sun sustains life on Earth in many important ways. Of course, the secular folks try to deny all of this, try to say that there is no creator behind it all. So they propose alternate explanations for where the sun came from and why it's there in the solar system. And this is an interesting question that's broader than just the sun, because The secular people tell us that the sun is just one example of a star. So you ask the secular folks, where do stars come from? And they'll tell you, oh, yeah, well, we know how stars formed without a creator. In fact, we've seen evidence of it happening. Famous photographs like this, where we're told that there's this cloud of gas out in space, and we see stars forming at the little fingertips and all the rest of it. Well, setting aside the fact that we see clouds of gas, this process is supposed to take millions of years. Of course, we haven't been watching that long. We've only had telescopes for a few hundred years, and photography even much shorter than that. So we've never actually seen a cloud of gas turn into a star, have we? How is this process even supposed to happen anyway? Well, what we're told is there's these clouds of gas out in space, which is true, we do see clouds of gas, and that gravity will compress these clouds, which is also true. All the molecules of gas are pulling on each other via gravity, and that when you collapse a gas cloud, it squeezes together, well, the temperature and the pressure go up inside. And if you keep squeezing it together by gravity, eventually the pressure and the temperature get high enough that nuclear fusion ignites inside the cloud, and then by definition you have a star. You have a tight ball of gas with nuclear fusion going on inside. Now, everything in that description is true, but it's incomplete. Gravity is not the only thing at work inside of these clouds. There's also gas pressure. Gas pressure is actually driving the gas molecules apart rather than pulling them together. So gravity and gas pressure are fighting each other. Which one is the stronger? Gas pressure is, by far. Now, once you have the gas dense enough, gravity becomes strong enough to hold it together as a star. So once you have a star, the star can remain and be stable. But before it's a star, when it's still more diffuse than that, gas pressure is by far the stronger effect, and clouds of gas will dissipate rather than collapse under gravity. Here's another way to look at this. Here's a gas cloud, and here's space. Now, by definition, in a gas, all the molecules are unattached from each other and all bouncing around in different directions. So in here, inside the cloud, the molecules move a little bit, bang into a neighbor, bounce off, and they just keep doing that, right? Moving around. Picture now, think of the layer of molecules right on the edge of this cloud. Now, since they're all moving in different directions more or less randomly, half of them are going to be moving some variety of inwards. Whether that's straight into the cloud or at an angle or whatever, some variety of inwards. And they will contact the neighbor and collide with it and bounce off, etc. But the other half of those molecules are going some variety of outwards. Whether straight out or whether at an angle, whatever it is, there's no neighbor for them to collide with, is there? They're going out into space, never to return. So you see, this cloud will lose the outermost layer of its molecules. That exposes the next layer. What used to be the next innermost is now the outer layer, which gets lost to space, which exposes another layer, which gets lost to space, and so on. So you keep peeling the onion until there's no onion left to peel, right? That's how this works. So yes, gravity is an effect within these clouds, but it's far weaker compared to gas pressure, which means the molecules are being driven apart, driven outwards to escape into space, and the clouds will dissipate, not collapse and form stars. Are secular modelers aware of this? Well, yes, they are, and they propose several solutions. Some of the more common ones are compression, cooling, and collision. So let me take a moment to talk about these. Compression is thought to occur as a result of supernovae. Supernovae is the plural of supernova. So this is a supernova next to this galaxy here, and a supernova is a very violent explosion out in space. We've seen some of these happen. We've also seen leftovers of when they happen. For example, the Crab Nebula is the leftover of a supernova that happened in the year 1054. Chinese astronomers recorded this. It was actually visible in the daytime for several days. Very, very violent events. So the thought is this: a supernova happens next to a gas cloud. Now the gas cloud, left to its own devices, won't collapse under gravity, but the shock front from the supernova compresses the cloud further. That then gives gravity a boost, if you will, and compresses the cloud down to the point where gravity can take over and continue compressing it, making stars within it. So compression is the first proposed mechanism to overcome the star formation problem. Then there's cooling. So picture you have a pot of water on the stove, just barely beginning to boil, and you dump in a bunch of rice. what happens to the water? It stops boiling, right? Why does it do that? Because the rice absorbs heat from the water. Well, if you have a gas cloud in space and you blow a bunch of particles into it from one of these explosions, well, the particles absorb heat from the cloud. And the way gases work is when you cool them down, pressure diminishes, gas pressure diminishes. That means gravity becomes relatively stronger than the gas pressure, and if you cool the cloud enough, then gravity can take over, keep compressing it, and stars can form. So we had compression from supernova explosions, we have cooling from blowing particles into the cloud, and the third proposed mechanism is collisions. I'm showing you a photograph of two galaxies colliding. And right along the collision front here appears to be new stars. Blue stars, which by anybody's understanding have to be young because they don't last very long. So this makes sense too. If you have galaxies which have stars and gas clouds within them, and then crunch those together, well, gas clouds colliding, that's a lot of pressure, right? A lot of compression, I should say. That'll overcome internal gas pressure, which then hopefully gravity can take over and make stars. So I've told you there's multiple explanations for how the secular modelers overcome this formation issue. But there's something I left out of these explanations. Maybe you can spot it. I told you that supernovae are big explosions out in space, but I didn't tell you what is exploding to make a supernova. The answer is a star. Not all stars will go supernova, but every supernova is what used to be a star. What about grains and particles to cool these clouds? Where do grains and particles come from? Turns out the Big Bang can't make any matter like that. Big Bang can only have made hydrogen and helium and a little bit of lithium. And actually couldn't have made anything, period, but we're granting them their assumptions. Even if you grant that the Big Bang were possible, it still couldn't make these grains. Those could only have been produced by nuclear fusion inside of stars. And of course, for galaxies to collide, they must first exist. And what are galaxies made of? Stars. So in order to make stars, according to the secular model, what do you first need to exist? Stars. So what does this remind you of? It's the ultimate chicken and egg problem, right? Just like you need eggs to make chickens and chickens to make eggs. The secular models need stars to exist before more stars can be made. Don't they recognize this? Well, yes, they do. As this author wrote, the process by which an interstellar cloud is concentrated until it's held together gravitationally to become a protostar is not known. The origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. Who hears this perspective in the science media? Here's one of my astrophysics textbooks. Literally hundreds of ideas on how stars are formed have been advanced in past decades. However, we are still far from any real solution. There are so many uncertainties in this picture that at present, we do not really have a theory of star formation. If stars did not exist, it would be easy to prove that this is what we expect. The universe we see when we look out to its furthest horizons contains 100 billion galaxies. Each of these galaxies contains another 100 billion stars. That's 10 to the 22 stars all told. A one with 22 zeros after it. That's a lot of stars. The silent embarrassment of modern astrophysics is that we do not know how even a single one of these stars managed to form. There's no lack of ideas, of course, we just can't substantiate them. The formation of stars is one of the most fundamental problems in astrophysics. No current model can reproduce all the observations. Well, that last sentence isn't true. The biblical model works just fine. Great is the Lord and of great power. His understanding is infinite. So what you aren't being told about star formation, and then by extension, the sun's formation, it requires gravity to pull gas clouds together, but that's very weak compared to gas pressure, which will force them to disperse instead. The explanations need old stars to exist before new ones can be made, which implies, therefore, you don't have an explanation for where the first ones came from, if you're a secular model trying to deny your creator. The sun specifically also produces further problems for the secular model. For example, supposedly the solar system formed from this cloud of gas, which formed into a disk shape, and then the planets formed out here, all going in the same direction, and notice this disk shape where they all line up with each other, and then the sun formed in the middle. Problem is, the sun doesn't look like it formed that way. Here's the sun, here's the planets. Now all the planets are aligned in what's called the plane of the ecliptic. Their orbits, as they go around the sun, like I said, are in a disk shape. Now if the sun formed from this same spinning gas cloud, it too should have its equator here. and its north pole here and its south pole there. Right? If this disk formed everything, then the sun in the middle should be spinning the same way, but it's not. It is spinning in the same direction, but it turns out the sun is actually tilted over by 7 degrees with respect to the plane of the ecliptic. So its equator is down here, not here, and its north pole is over here rather than being straight up and down here. Now 7 degrees doesn't sound like much of a discrepancy, which is why a lot of secular modelers try to ignore this. But when you do the math, there's a problem here. This diagram is not to scale. These planets are roughly this size compared to the sun, but in reality they're much further away from the sun. If you wanted to build a scale model of the sun, and you started with a grapefruit for the sun, Neptune, which is the farthest planet away, would be about the size of a pea, and you'd have to put Neptune 300 yards from where your grapefruit is. That's how big the solar system is. Now I'm explaining that to picture, if the sun were tilted by 7 degrees relative to all the planets, how big is the discrepancy by the time you reach out to the orbit of Neptune? Well, the answer is about 343 million miles. So the sun does not look like it came from this spinning gas cloud, does it? Moreover, the sun also presents secular modelers with something called a faint young sun paradox. Our understanding of solar physics says that the sun is going to be slowly changing its temperature over time. The sun is supposed to be about 4.5 billion years old. If that were true, which is not, but if it were, several billion years ago, when life on Earth was supposedly starting to evolve, the sun would have been about 30% cooler than it is right now. Thus the faint young sun. When the sun was younger, it would have been cooler than today. That would have put the Earth into being more or less a permanent ice ball back then. Life would not have been possible. So for secular modelers trying to believe in the billions of years and millions of years of evolution and etc., solar physics says that doesn't work. And then there's the overall atheist view of this whole system. Carl Sagan made a comment that you've probably heard different people express. He said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people." You've heard comments like this from the science media, right? The sun's nothing special, humdrum, ordinary, insignificant. Our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity. Our sun, so important to us, is merely an ordinary garden variety star. This is not true at all. Instead, the sun is an excellent example of the Lord showing his glory through what he has created. The sun is not mediocre at all. First of all, it's brighter than 90% of all stars in the Milky Way. Is that average? Greater than 90%? No, not at all. It has more mass than 92% of the stars. In fact, about 3/4 of all the stars we see are red dwarfs. If you're thinking of an average mediocre star, this is what the sun would look like. A red dwarf is called a red dwarf because it's small, thus the dwarf, and it's cool, thus the red. It produces red dwarf typically 5 to 10% of the energy output of our sun. Now, if the sun were actually an average star, we would be orbiting one of these, not one of those. I should say one of those. Our sun's unique. We wouldn't be orbiting this. We'd be orbiting one of these. Now, this, of course, produces so much less energy, we'd have to be orbiting it very closely. So closely, in fact, that the Earth would be tidally locked to where the same side of the Earth would always be facing the sun. You've probably heard this about our moon, right? The same side of the moon always faces the Earth, regardless of where you are. Same thing here. If we were orbiting an average star, we would be orbiting a red dwarf, which is cool enough, we'd have to be very close to it, which would tidally lock the Earth to it. And so one side of the Earth would be permanently lit and irradiated, and the other side would be permanently frozen. Obviously, this is hostile to life. Furthermore, red dwarf stars are very unstable. They're commonly called flare stars because they frequently erupt and massive amounts of stellar material blasts out into space, sterilizing anything in its path. Well, good thing we don't orbit one of those, right? But that's what an average star is. Even among high-mass stars, 80% of those are in binary or multiple star systems. Like a binary system is where two stars orbit their common center of mass. As you can imagine, if the Earth orbited one of those, we have a lot of different effects on our climate here, because sometimes there'd be one star irradiating the planet, and sometimes there'd be two, depending on where you were in your orbit. Furthermore, the Sun is a Class G star, which is only 7.5% of all stars. Again, not average, not mediocre at all. And even among Class G stars, our Sun, as far as we can tell, is unique. Our Sun is unusually quiet. What do I mean by quiet? Well, a 30-year study of the Sun's photosphere, its surface, was finished recently, and they found that the energy output of our Sun varied by less than 0.1%. Now, we take that for granted, right? I mean, we get up and the Sun goes up and it goes down, at least sometimes of the year, the times we see it, and we don't think about the Sun. But stars don't act this way. Even solar-type stars, of which our Sun is an example. Some studies have been done on solar-type stars, found that even solar-type stars frequently have superflares. What is a superflare? Well, you may be familiar with the fact that our Sun's surface is not calm. It's a seething, massive activity. There's a lot of really cool stuff that goes on here. But once in a while, there's a flare, and it's usually accompanied by a coronal mass ejection, a CME, where some solar material blasts off into space. And people worry about one of these hitting the Earth because it'll knock out some communication satellites or so on. You can see the size of these things compared to the Earth, but they're typically fairly moderate. Even the ones that have actually affected the Earth haven't had much of an impact. Well, imagine one of these that's 10 million times greater. That's a superflare. And as these studies have shown, even solar-type stars have superflares about once per century on average, once every 100 years. Now, that's really often if you think about it. Now, wait a number of years and you're going to get hit with one of those. What is that going to do to life on whatever planet may be orbiting that star? Bad news, right? And again, this is what solar-type stars do, except for our Sun, which has never had one. As this article said, Sun-like stars normally produce a bright superflare about once a century. But why a superflare has not occurred on the Sun in recorded history is unclear. Well, it's not unclear at all. If an omniscient, omnipotent, benevolent creator made the Sun to sustain life on Earth, then we shouldn't be surprised that that's exactly what it does. For perspective, there are some very violent things we see going on in space. Now, these are extreme examples, granted, but just to get us thinking about these things, this is, in the middle of that, a star that is in the process of making a very violent explosion. Anything that was in the path of that, of course, has not done very well. This here, too, in the middle of that is a star. This is actually a dual-lobed explosion going up in a couple different directions. Again, stars are very violent things. We can't see that with our eye most of the time. They're all like that, as best as we can tell, one way or another, except for our Sun. As this author said, some of the popular perception of the Sun is downright wrong. Writers sometimes tell us that it's just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the Sun. This author said, people say the Sun is a typical star. That's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden, places like Earth, where it can exist. And I like this quote because it's the New York Times talking about a Garden of Eden, which ironic. So the Sun does not look like the example of random processes as the result of this Big Bang event. It is unique and designed very well for us. And as I mentioned earlier, even some secular authors admit this. Now, this is a whole topic in itself, but there's a book written by two secular authors from UW here, listing all of these various things, which I won't bother taking the time to describe, all these various things in our solar system that are essential for life on Earth, even if you want to accept the whole Big Bang billions of years thing. And again, we don't accept the billions of years, but it interests me that the Lord has created things in such a way that even the best efforts of creation deniers still are forced to acknowledge amazing amounts of fine-tuning, amazing amounts of apparent design, and all these things that are necessary for life to have been possible here, even in their secular models. And I'm not reading these, obviously. I'm just showing you the length of the list of all the various things we would be talking about if we wanted to deal just with all the apparent fine-tuning that we see in the heavens around us. So, in summary, we talked about the 3 bodies that are going to be involved in this coming eclipse. And again, we could do similar discussions on every single planet in the solar system, along with a lot of other stuff in the heavens besides these. The coming eclipse is indeed presents us with many reasons to contemplate about the many ways in which the heavens declare the glory of God and the heavens show the work of his hands. Because indeed they do that very well in many more ways than we can even comprehend. So my time is coming to a close. This may be a new perspective on astronomy, probably to many of us. If you like this kind of perspective, my website's creationastronomy.com. I have a free email newsletter available to you there. It comes out fairly infrequently and it won't get spammed to death. You can unsubscribe anytime you want. That's there if you would like it. And I believe it is now time for the benediction. I thank you for your attention. Oh, and I should also mention, we'll be either up here or downstairs, but anyway, 6 p.m. 6 p.m. Okay, I thought it was 7. 6 p.m. tonight, we'll be back here meeting. When you start talking about creation versus evolution, a lot of people will ask, well, what about fossils? What about dinosaurs? What about billions of years and age of the earth? That will be our subject tonight. And as you can perhaps guess from the presentation this morning, we'll talk about the evidence that is presented as proof of the secular view. We'll show why it actually doesn't say that, and we'll present further evidence that says the secular view is all washed up because the creation is the result of the Lord's work. So thank you for your attention. It's my privilege to be here with you this morning.
Before the benediction, you can stand and sing hymn number 534, Face to Face with Christ my Savior.